I'll try to keep this to about an hour so that people have got a time to take a bit of a break before we head off. Okay, so here's my outline. Why a national research data grid? It's a very ambitious program which is going in Australia right now. It's got a lot of federal funding for it. I'll also talk about the Australian cyber infrastructure landscape, because as with everything else, I often find, oh, well, you could do it this way, and then I immediately find from Canadians, well, you could, except for, this is controlled by the province, this is controlled by, the feds, there's this funding arrangement, and so on. So I want to talk about how we do cyber infrastructure in Australia. I'll do one example of a really neat cyber infrastructure tool that we've built in Australia that's going into production mode now. It's called BioGrid. What it does is it links together clinical research data. So if you have researchers working in, say, cystic fibrosis, gathering data, they can share it across multiple different sites securely and do much larger studies. I'll talk about challenges of the National Data Grid. We're just starting in this right now. I'll talk about the architecture. I'll talk about research opportunities and challenges a bit. And finally, some lessons we've learned in the cyber infrastructure game in Australia over the last decade. So why a national data grid? Now, the motivation for this is that traditionally, individual researchers had to maintain their own data. So it was your responsibility to maintain your data. Some communities, like high-energy physics or astronomy, have very, very good archiving of data. I mean, the clear reason is that in astronomy, you never get to repeat your experiment. Essentially, you can't turn time backwards. Once you've made a measurement, you need to make it available to people. But other users typically, gather the data and it sits on, CDs somewhere or someone's hard drive. Not just the data itself, but often the models and analysis needed to do it. So I recall plenty of times people have come to us and said, well, I want to get access to a paper you published a few years ago. Can you give me the software tool? And I said, well, the graduate student that did it, Reed Harmon, he's graduated, he's gone on, good luck, Or other cases where I remember where I'm looking at papers in geophysics journals and I'm looking at this graph. And so what I'm doing is I'm trying to blow up this copy of a graph and draw my graph on top of it and figure out if it looks faintly the same. It's very depressing. What you want is access to the original data and also the method by which it was generated. Okay, so sometimes being able to reproduce results is just not possible. I guess many of you have seen the papers in the arguments about the Nature results where there was various forgeries of research data. There have been several cases of this, of leading researchers, where you can see the image of this looks the same as the image of that. The question is that the tip of the iceberg, or are there more problems out there? The other case which is important, for example, is in clinical trials data. There have been many cases where clinical trials have been done. There's an argument as to whether perhaps if we looked at that data a little bit more closely, we might have detected some symptoms or some side effects or something that was going wrong. The other point about it is that archival data has great value. One of the best cited examples is the Hubble Space Telescope. If you use the Hubble telescope, you're required to archive your data with the Space Technology Institute, STSI. The statistics are that more than twice as many papers are published with recycled data on the Hubble than are actually published off the original data. The fact that that data is there and searchable means it can be reused. Other famous measurements, the British Navy, you had a habit of going around the world and taking things over and establishing new countries and so on. The one thing they did was they measured ocean temperatures a lot. That data is still available now, and that actually ties into things like global warming. Again, at the time, I'm sure the naval engineers didn't think, oh boy, we might have a global warming problem in 2 decades. They were more worried about the French. Okay, but of course you're not worried about the French in Canada. Okay, so other examples, biomedical data. We're doing a lot with this now, MRI records. Old records people have taken that they want to digitally rescan and process. Now here's the kicker. In Australia recently, there's been a national code of conduct that the equivalent of NIH, the NRC and NSF have all said that if we fund research, the research institutions have got a responsibility to archive that data. Now, this has put the fear of God into the universities because they're worried about, a lawsuit coming on down the track or somebody contesting some work that they've done. So this is an exact quote from the Code of Conduct. You have to retain the materials to justify the outcomes and to defend them if they're challenged, not just the raw data, but how it was generated. Now, I suspect that Australia is a little bit forward in this, but it's only inevitable before other research agencies start to require this. In particular, the value of the research and whether you can repeat the experiments. The other thing that we've convinced the federal government of and the universities is it's not effective, it's not effective for each university to maintain its own archives. In many cases, research is multi-institutional, multidisciplinary. All that the Commonwealth has set up to now is that if researchers are working at two different universities, then you are going to have to agree on who's going to share the data and have an agreement. Well, that's great. How many universities are there in Canada? 40, and that's 40 times 39. If it's 3 people agreements, you're looking at 250 odd different agreements. It's not effective. So this is the motivation, essentially. It's, look, we need to get organised in terms of nationally providing tools and resources for researchers to archive their data. So this is a nationally funded effort. About $100 million worth of money in Australia has gone into this. So it's a non-trivial effort. Multiple groups are being funded. We are being funded to do it. Another large organisation I'll talk about in a minute. The universities are being asked to make co-contributions as well. It's expected to be, this $100 million is to be spent over 3 years. So the government's keen to burn some money. That, of course, puts huge risk on things, and I can talk about it later. So the next thing I want to talk about is cyber infrastructure in Australia. Again, in some ways it's similar to Canada. It's quite dissimilar to the US and the UK, though. So it's very differently organised. In Australia, it's almost, I would say, we have a real advantage in the sense it's all organised top-down, in a way that there's very little overlap between the different constituencies, and yet there's a lot of collaboration. The good thing is there's only 40 universities in Australia and only about 20 million people. There's one national government research agency called Cybera, who can be very painful, but there's only one of them. We have a national research telecom that's equivalent to, in some ways, Canary. It's the same type of operation. It runs research data between the universities. We work with them, there are local tails and so on. Since about 2005, the Australian government did a survey of the large collaborative research centres it funded. So the policy in the past used to be one of going out for competitive bids and then looking at the best bid that came back. Typically what that does is it results in a year worth of pain and suffering forming sort of national consortia between competing groups, hundreds of pages of paper printed and trees wasted, then another year recovering from the fact that you've got the collaboration. Usually the collaboration was an artificial one just to get the money. So that the data that the government had was that only about half of the national centres could be argued as being efficient and effective. And so there was a policy around all research infrastructure dating back to about 2005 that there could be no competitive bids anymore. It had to be done by national collaboration. If you didn't have collaboration, we wouldn't fund it. Come back when you're organised. So this is great. The other point is that each state or each province essentially has one single e-research or high-performance computing provider. So it's not the overlapping constituency you've got in the United States. It's even more centralised, I guess, than Canada. So if you take Ontario, you've got several HPC groups there. You've got Waterloo, you've got Toronto. We are essentially the HPC service provider for the state. There's also one single national organisation for cyber infrastructure with 3 components: grid component, data component, and a compute component. And so the group that's responsible for grid computing and cyber infrastructure services is called ARCS. The Australian Research Collaboration Services is the acronym for it. There's a website there. Essentially, this is a federation of the state facilities. So it's like, the Canadian Federation